Hi guys, so let's talk about section 8.3, graph and write equations of circles. This is not too bad, I think. We start off again with deriving the equation for a circle, which is also pretty simple, and you'll see also relies on Pythagorean theorem. And then we'll do some graphing questions and some writing equation questions, and then we'll get into some problem solving for tangent lines to circles, and basically like area in a circle. Are you inside a circle? Are you outside a circle? Things like that. Okay. So I'm not going to do every single example on the note sheet because I want to make the video as quickly as possible for you. So I'm just maybe going to do the first example and then you can try the second example, or I'll try and do a more difficult one and you can try the easier one if you want. Okay. And please remember that the completed note sheet has all this information on it. So we started with deriving the equation. So derive the formula for a circle with its center at the origin. So everything we're doing so far, all our conic sections, the centers are at the origin. So I'm going to draw a picture, a fairly ugly, quick picture here. Here's the origin, 0, 0, x and y. I mean, if you want to do this properly, but this is not necessary, you can put some arrows there and label the axes. And then we're just going to say, here's a point. Okay, so derive the formula for a circle with a center at its origin. I can draw my circle. Okay, there's my circle. And then I'm just going to say, let this be any point on the circle. Now you can put the point anywhere, but I'm doing it here because it makes everything a bit easier to derive. Okay, and then all we're going to do is say, now, if you remember what the definition of a circle is, sorry, I should have said that first. A circle is the set of all points x, y in a plane that are equidistant, the same distance from a fixed point. So the definition looks like this. There's a point that's this distance, we call it the radius, from the center. But I could make another point here that's that distance, and that distance, and that distance. So the definition literally says that a circle is just all the points that are the same distance from the center. Okay? So let me erase all that stuff. And so what we're going to do is use that information to derive the equation. So I just picked this point. Again, you can use any one. And then I'm going to call this distance r for radius. Okay? Because that's what we call the radius, distance from the center of the circle to the circle itself. Okay, and then you can drop in an altitude at a right angle. Okay, and then we can label some things. So let me remove this, and then we can label some things. Oh, and you can notice something very special. Now I have a right triangle, and that always brings to mind Pythagorean theorem. So what is the distance of this, or the length of this side? Well, if that coordinate is x, then the distance is x, or the length is x. And then how about this? Well, if this coordinate is y, I'm currently at y over here, then the length here is y. Okay? And so this is the information I'm going to use to write the equation for the circle, and it's ridiculously simple. Okay, but this is what we're going to use to derive the equation. So all we just say is this: using our sketch or diagram, I guess we should say diagram, not a sketch. Using our diagram and Pythagorean theorem, we see the following. Okay, x squared, which is one of the legs, this one, plus y squared, this leg, is equals to r squared. And since we just picked this point to be any point on the circle, you can say this is true for every point xy on the circle. Okay, So I had a question the other day about someone saying, well, if I'm deriving a formula for something, do I have to write a bunch of sentences? Kind of yes and no. You have to write like, my logic here comes from my picture. Okay, so using our diagram, that would be good. And then say, what is it in my picture that allows me to make that statement? Well, it's Pythagorean theorem is what I'm using. Okay, and then this works for every point in the circle. You can't really write less than that. You must write some words. All right, you must write some words to explain your logic and at least explain what you're referring to. You don't have to write an essay, but you have to write some words. Okay, so if I'm using Pythagorean theorem, I've got to say I'm using Pythagorean theorem. Okay, so that's the equation of a circle. It's that simple. It's really beautiful. X squared plus y squared equals r squared, as long as the center of the circle is the origin. Okay. So here's a question that says graph the equation, identify the radius. All right. So let's talk about letter B. We'll do letter B, but just notice that there's a problem here right off the bat. Here is the circle that's centered at the origin. That's the form it's supposed to be in. And neither of these are in the correct form. Okay? So always standard form is what we want to go back to. So I want to make this look like x squared plus y squared equals r squared. That's not what it looks like. So I need to do x squared and then bring the y squared over and take the 18 over to the other side. Okay? So now I do have it in this form. So this tells me then that r squared must be 18. And if you take the square root both sides, and r means the radius, right? We said it earlier here. R is the radius, okay? So r is then plus minus, what does that give me? 3 root 2, something like that. Okay, and if I'm going to graph it, 3 root 2 is hard for me to visualize. You want to make that the approximate number at least. So 4.24, something like that, 4.2. Okay, again, very hard to draw. But drawing a circle, I mean, hard to draw this exactly, but drawing a circle is the easiest thing you've done in a very long time. So you just find the radius, 1, 2, 3, 4.2, which is about there. And you just go the same direction on all four directions on the coordinate plane. Okay, so you just do this, and 1, 2, 3, 4.24. Let's say it's there. I'm getting a little less accurate, and then just connect the dots with a circle. So my circle is going to be fairly hideous, but that's okay. We're just doing it by hand. Okay. If you look at my completed note sheet, I used a compass and everything looks very sexy there. So that's how you graph an equation. Graph a circle. If you've got the equation, you just find the radius and you draw, because that's the definition of a circle. It's the set of all points that are the same distance away from the center. And all of that will be 4.24. Okay? So every point here, infinitely many points that make up the circle there. All right. Okay, so that's the first, I would say, fairly simple example. The second example is write standard form of the equation of the circle that passes through the given point. And it's centered at the origin. Okay. So these two examples are both equally difficult or easy, depending on how you look at it. So you don't have to draw a picture. I'm just going to draw a picture to show you what they're saying. Okay, you don't have to draw a picture. If you struggle with this kind of stuff, maybe it'll help you. Okay, so what they're saying is this. This is a point on the circle. It's an XY coordinate point on the circle. And its center is the origin. So here's the middle of my circle, the center. And at 2, -5, I have a point. And that would be my circle. Something like that. Okay? So that's fine. Good. How do I write an equation for that? So I've got 2, -5. But we know the formula for a circle. Okay, we know the formula for a circle. And if you look up here, the equation of a circle, basically we know what the equation is as long as I know what the radius is. And again here, the radius is the thing that makes the whole equation work, okay? Because the radius completely determines the whole circle. So, all I have to do basically is take my equation, and if I can find out what the radius is, then I know how far every point is from the center. So all I have to do to write an equation for a circle is find the radius, basically. So let's do that. So what I'm going to do is just say, well, I want r squared. I don't know what r is here, okay? But if you notice again, basically I can drop an altitude here, do this, and do Pythagorean theorem. Pythagorean theorem is the thing that basically helps us come up with the equations. This is Pythagorean theorem, except for A, B, and C, we're calling it r, x, and y, okay? And so you just plug in the numbers. I have an x, I have a y, and I'm trying to find r squared. So I get 4 plus 25 is r squared. So r squared is 29. Now, our natural instinct usually is to go and find r, take a root and find r, but you don't have to do that because the formula that I'm looking to write is this. I'm looking to write x squared plus y squared equals r squared. Well, this is r squared. I don't have to take the square root. So don't write root 29, that would be incorrect. Okay, so this is the answer. Write the equation of the circle. That's about, I made that much more complicated than it needs to be. Basically take x, y, plug it in the formula, and you're done. But this is what you're actually doing when you do that. Alright, example 3. Remember that a line that is tangent to a circle, now remember here means, hey, remember from geometry, almost 2 years ago, okay? Well, almost a year ago, that a line that is tangent to a circle is perpendicular to the radius at the point of tangency. So, this is, I'm going to label this and then we'll do example B, letter B. This is the tangent line, okay? So they're saying, remember that a tangent line to a circle, this being the circle, is perpendicular to the radius, this is the radius, at the point of tangency. So the point of tangency is where the tangent line touches the circle. It only touches the circle once, in that exact point, okay? This is very useful information for us to come up with the information we need, okay? Now the question here is, write the equation of the tangent line. This, what is the equation of this tangent line? Okay, now my first suggestion to you, this is great, they gave you a picture. My first suggestion to you would be draw a picture. So that's why we'll do this one, letter B. And then notice there's something else. It says, right, what is an equation? An equation of the line tangent to the circle. This is not telling you how to write the equation. It just says find an equation of a line. So I'll show you two different things, but actually you can make this easier on yourself or you can go all the way and make it a little bit harder on yourself. Okay, so a lot of information here. Actually, I'm going to do letter B. Okay, so remember this fact. Okay, remember this fact, and then I would draw a picture if I were you, and then find the equation of the tangent line to this circle here. Okay, so here's what it's saying. Draw a picture. Okay, and of course all these circles of ours in this section again are centered at the origin. Unfortunately for you, later on you'll see, I think it's section 8.6, everything is not centered at the origin anymore. That's kind of tricky, but for now it's still simple. And they're saying the point of tangency on the circle is at 5, negative 6. 1, 2, 3, 4, 5. And negative 6. 1, 2, 3, 4, 5, 6. There's 5, negative 6. Okay? So, we can draw the circle at this point. We can draw the circle at this point. There's my circle. Okay? It looks something like that. Please, that's hideous, but it looks something like that. Okay? And so here's my point. 5, negative 6. And again, visualize what is it that you're trying to find. The equation of the tangent line at the point 5, -6. So here's what I'm actually trying to find. There's a line here that's tangent to the circle, and it is, by definition, from geometry, perpendicular to the radius. Okay, perpendicular to the radius. Now, you have to think back to Algebra 1. What do I need to write the equation of a line? Okay, the minimum information I need to write the equation of a line is a slope and a point. Okay, so, and we saw earlier in section 8.1 that we have a formula that's called point slope form. Some people are asking, do I really need to know this? The answer is yes, you need to know this. Please know this formula. Y minus y1 equals the slope times x minus x1. You're going to use this even in pre-calc and calc more than we are, so please know the formula. Okay, and then if I just need a point and a slope of the line that I'm trying to find the equation of, that's all I need. Okay, so I have a point on the line. This is the tangent line. I just drew it there. The tangent line, and they told us touches the circle here. So that is the point. So I have a point on the line. Great. So I have taken care of this information, my y1 and my x1. I have that information. The missing thing for me to write an equation of a line is the slope here. Okay, the slope. So let's find the slope. Now think about it a little bit. How can I go about this? How can I find the slope of this line, the tangent line? Well, to find the slope, let's go through that exercise. The slope is rise over run. But rise over run means I have to be able to count from one point, rise, and then run to the other point. But I don't know another point on the line. I don't know that. I can't make it up. Or I need to know this, y2 minus y1 over x2 minus x1. But that again requires 2 points on the line for me to find the slope. So I can't use either of these strategies. So what I'm doing is this. I'm using the fact that I have 2 points on this segment right here, which is called the radius. So I can find this slope. Let me call it like the slope of the radius, m sub r or something like that. Okay? I find the slope of the radius, and then from geometry in Algebra 1, I know that this tangent line is perpendicular, so the slope of the tangent line would be the negative reciprocal of the slope of the radius. Alright, that's a lot of information, a lot of review stuff there. Okay? So let's get in there and do that. So let's do this first. I have a point. Good. All I need to do is find the slope. Okay, so my strategy is, number one, find the slope of the radius. Okay, and this is the same for all of these questions where they're saying find the equation of the tangent line. So find the slope of the radius. Now, I can use this formula. Slope equals y2 minus y1 over x2 minus x1. And I need 2 points. But, good news, I have 2 points. 0, 0 is the first point on my radius, and 5, -6 is the second point on my radius. So I can go call this x1, y1, and I can go call this x2, y2. I have the 2 points that I need. So you just plug stuff in. Okay? So you say, basically, y2 is -6 from here, and then y1 minus y1, minus y1, which is 0, over, and then x2, which is 5, minus x1, which is 0. Okay, so here is -6 over 5. If I subtract nothing, I just get -6 over 5. So that's the slope of the radius. So we can call this m sub r. Okay, m sub r. The slope of the radius here is -6 over 5. Okay, that's great, but that's not actually what I wanted. I want the slope of the tangent line. I want m sub t. Okay, and that is what? Now, this is easy because I've already done the hard work now. So I just have to use some logic. So find the slope of the tangent line. But that's simple because the slope of the tangent line, let's call it m sub t, is just the negative reciprocal of the slope of the radius. Okay, so all you have to do is say the negative of this slope and take its reciprocal. Okay, so if I take the reciprocal of this, I get negative 5 over 6, and the negative of that, which is just 5 over 6. Okay, so there is my slope of my tangent line. M sub t, we found it down here. This is 5 over 6. Well, now, good news. I have the slope of the green line, and I have a point on the green line. So if I slope of the green line and a point of the green line, I can go ahead and find the equation for it. Okay, so 3, you just find the equation. Okay, and so let's find the equation. All right, so I'm using point slope form. Point slope form, please, you must know this stuff. Point slope form. Let's see if I can just bring this sucker down from here. Beautiful. Love the technology. Okay, and so now I can do this. Y minus y1. So on my line, again, we're trying to find the equation of this line. So on my line, what I have is, this would be called x1, and this would be called y1. Sorry. And that's my slope. So I just plug that stuff in. So y minus y1, which would be negative 6, equals the slope, which is 5 over 6, times x minus x1, which is 5. Okay? And I'm just, at that point, actually, to be honest with you, since there is no specification of how to write the equation of the line, technically at this point you are done. They didn't say write it in point slope form, they just said write an equation of the line. Okay. Now, I know most of you like point slope form. Point slope form is the easiest form to use to graph a line if you're given the equation or you want to graph a line. So I understand you want to do that. So naturally, most students want to do this kind of stuff and say 5 over 6 times x distributed minus 25 over 6, something like that. Okay, and then let's move it up here, and then you want to say y equals, take the 6 over and simplify that fraction. And what would that be? 6, like 36 over 6. So if I change this, it would be 36 over 6. So negative 25 minus 36 is negative 61 over 6. Okay? So that's point slope, but just remember I said, technically, this is fine. You can stop here. That is the equation of the line. They didn't say right in the slope intercept form. All right, so that's letter B. Quite a bit more tricky, quite a bit of prior knowledge. You need to do that. Okay, hopefully I reviewed some of that stuff here with you. All right, and then we get into some problem solving. So circles and inequalities, they give you some information. We'll look at this in a second, and then you have to solve some problems. Okay, 2 problems you have to solve. Example 4 and example 5. These are a little bit more tricky, and you don't have to quite do them exactly the way I do them. I'm going to use the textbook information, but you can use your mind and do something different if you really want to, okay, and still come up with the right answer. So the textbook tells us this information, okay, here. The regions inside and outside the circle that has this equation, so any circle, in other words, that centers at the origin, can be described by these inequalities. X squared plus y squared is less than r squared, representing the region inside the circle. So let me do some highlighting, creative highlighting. You should probably do the same. This is the area inside the circle, and let's use a different color. This would be the region outside the circle. Okay. So The picture here shows you this. This inequality represents all of this area outside the circle. Okay? And meaning if a point satisfies this inequality, then the point is outside the circle. And this inequality right here covers all the points inside the circle. Okay? And again, what that means is if a point is in here and I plug it into this inequality, it will satisfy it correctly. It will work. It will give me a true statement. All right? That's all it means. That's all it means. So, let's just keep that knowledge in mind. Okay? Think about that. We'll do a example here together. Okay? So, you work for a movie production company and you are tasked with scouting good filming locations. You must set up a lot of equipment for a television set to broadcast from a remote location, so you need to determine if you are in range of any relay towers before setting up. Okay. According to the approximate route you drove from the signal relay tower, you are now 40 miles west and 90 miles south of the tower. Okay. So there's a tower, and I'm this and this, okay? At a desirable broadcast location. Are you within the tower's 100-mile range? Whoa, a lot of stuff going on here. Okay? So, first of all, let's draw a picture. All right? You have to represent the situation correctly. So, I must set up a lot of equipment to broadcast from a remote location. I need to determine if I am within range of a relay tower. So this is what this means. Let's say the relay tower is the origin. Okay? Picture this being a relay tower. Alright? Alright. There's the relay tower. Relay tower here, what we're talking about is from my camera equipment, I send a signal wherever I am. Okay, let's say I'm over here. From my camera equipment here, here's Charlie smiling, and I'm filming him, okay? This is sending the signal to the relay tower, and then the relay tower can send the signal on somewhere else, okay? So, this is what we're trying to check. The location that I picked, am I in range of the relay tower? And the relay tower's range is 100 miles. So if I just go 100 miles this way, let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's say this is my 10th tick mark here. All right, let's say this is 10. So we call this 100 miles. Okay, 100 miles. So if I go by tens, 10, 20, and so on. This is 100 miles. So that means that the relay tower's range would be about this. Okay. Now, it's better if you draw this perfectly with a compass or a protractor or whatever, but, you know, we're just doing it by hand. And you're going to be solving something like this on a quiz or a test. Just do it by hand. Just do it quickly. The point is you want to visualize what it is we're trying to do. Okay? And so, are you within the tower's 100-mile range? So, what happened? I drove to a desirable location, and I am 40 miles west. Oh, this introduces more problems. Where's west? So, north, east, south, west. Okay? I'm 40 miles west and 90 miles south of the tower. So west would be 40 miles west. 1, 2, 3, 4. There's my 40 miles west. And then I go 90 miles south. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's definitely not correctly drawn to scale. But in any case, 9 would be more like here, 90 miles south. Okay? And so here I am. I drove this way 40 miles and then I drove south 90 miles. Okay, now my picture is making it look like we already know the answer. The answer is, are you within the tower's range? And I'm saying, yes, looks like it. There I am. But we can't just do that. You have to show it mathematically. Okay, I can't, especially since I drew my picture by hand without any actual equipment or precision, I definitely can't trust my picture. Okay, so here's where I am right now, and we can call this, like in a coordinate plane, we'll call it -40, -90, because I went left and down. Okay, or 40 west, 90 south. Okay, 90 miles south. I should put S there, not M. Okay, and so am I in range? Well, all we do is use the inequality. Okay, so if I'm in range, I should be this. Okay, if I'm inside the range, I should satisfy that inequality. Okay, so I have to satisfy this inequality. X squared plus y squared. Is my location less than the radius? Is my location less than the radius away from the center? Here's the radius. Is my location closer to the center than the radius? That's the question. So now we just plug in the numbers. Once you've done all the thinking, you just plug in the numbers and see what happens. So this would be x coordinate, this would be y coordinate of where I am, and how does that relate to the radius? Well, we know what the radius is. The radius is 100. That was given to us right off the bat. Okay, so I have -40 squared plus -90 squared. Is that less than the radius, which they gave me right off the bat? And we're just checking this out. So 1600 plus 8100, is that less than 10,000? That's the question. And if you don't already see that, you can just do this and say, check my location. So let me draw my location's distance in a different color. Let me do green since I'm on green. This is how far I am from the relay tower. That distance is 9,700. Sorry. That distance is the square root of 9,700. Okay, the square root of 9,700. And the radius of the relay tower goes that little bit extra distance right there. Okay, so the radius is a bit longer. So what you say is, yes, I am in range of the relay tower. Okay, that's what you say. All right, so that's example 4. Then the next example is similar, using, I think, the same picture. We can hope, and it says, from example 4, thank you, suppose that after conducting a land survey, you determine there are potentially dangerous geological features such as sinkholes and the potential for mudslides due to heavy rain in the regional location. So you'd figure out that this place is not a good place. I can't be there really. I got to get out of there because we don't want to film there for a long time. We're going to get ourselves in trouble. Okay? So you decide to drive due north, straight up north. You decide to drive due north to investigate terrain to the north of the relay tower. Okay, so here's the relay tower again. So I'm going to go somewhere to the north of the relay tower. How far can I drive while scouting terrain and still be in range of the tower? So here's the question. How far can I drive all the way up here, okay, while still being in range? Okay. That's the question. How far can I drive while still being in range? Okay. So, one thing I know is I already know this distance. If I just use my existing picture, I know that distance. If where I am right now is -40, -90, and I just drive due north, then I'm going to get to the x-axis here in 90 miles. Okay, 90 miles is how far I am from the x-axis. So then really the only question is, how far is this distance? Okay, that's really the only question. But since it's a point on my circle, I can come up with some information. Basically, I'm asking what is the y-coordinate, because that would give me this distance, right? If I find the y-coordinate, then I have the distance from the x-axis. Okay, and I have the x-coordinate. If you look at this carefully, if I drove 40 to the west, which is negative 40 in the coordinate plane, and I went down to negative 90 or 90 miles south, if I just drive due north, it means I'm not going west or east, I'm just driving straight up. It means my x-coordinate is still negative 40. My x-coordinate is still negative 40. Okay, so what I know is that I have 90 miles that I've driven here. Okay, and I want to find out how far am I still driving from the x-axis to the edge of the circle. All right. So all I have to do there is say, how can I find the missing y-coordinate? So I have the equation of the circle. And what I'm doing is trying to figure out what is that y-coordinate. Okay, what is this y-coordinate? So all I do is plug in my radius, which we were given right off the bat. I plug in my x-coordinate, and then I plug in the unknown y-coordinate. I don't know this. Okay, and so I do the math here, and I get 1600, just like before. Y squared equals 10,000. Okay, and then I say y squared equals 10,000 minus 1600, 8,400. Okay, subtract that both sides, and then to find y, I just take the square root. So y is about, and this you do on your calculator, about 91.65 miles. Okay, so it means that this coordinate here is about 91.65, or 91.65 miles is how far north of the x-axis I can drive. But now please remember, that's not the actual answer. The answer is, this is the distance I'm driving here, plus the distance I drove from where I originally was. Okay, so my answer actually is, your final answer would be this, 90 miles plus 91.65 miles. And that would be 181.65 miles. Okay? Hopefully that works for you. Fortunately, we got to use the same picture again. Any case, guys, that's the end of that lesson. Please, if you need some more help, go look at the completed note sheets, and also you can read your textbook. Thank you.